phase diagram for water. Label all the axes, phases, critical point with temperature and pressure, and triple point with temperature and pressure. A, explain by referring to the phase diagram why ice floats on water. So a phase diagram is going to have pressure on the y-axis, temperature on the x-axis, and they all pretty much look something like this for these two parts. And what's different about, well, let me finish this one for water. This is going to be the phase diagram for water. And when I say phases, what I mean is we're going to put the solid, liquid, liquid, and gas phases on here. And then we're going to have two other points that it asks about. The critical point is going to be right here. And the triple point is going to be right here. Now, so drawing this is one thing. So the triple point is the only pressure temperature combination at which solid, liquid, and gas can coexist. That's what the triple point is. And the critical point, it looks like I have space up here to write about what it is. For the critical point, it is the point, or I'll say this, the pressure and temperature above which liquid and gas become indistinguishable. Which is pretty cool, though there's much more behind that we won't really get to talk about, but we will mention it. And then, and this is well, let's say this. I didn't put the temperature and pressure for the critical point, and I didn't put the temperature and pressure for the triple point. I have to look those up, so I don't have them in the back of my head right here, but I can look them up, and so that's what I would do. And I would expect you to label those. And now, let's answer A. Explain by referring to the phase diagram why ice floats on water. And let's see. So I'm trying to think of the best way to put this. So, so we're going to zone in on this line for the solid-liquid coexistence. You'll note that the solid-liquid coexistence line has a negative slope. And if I was to start right here and increase pressure, that's supposed to be a vertical line. Hopefully it doesn't look too bad. So start at dot and increase pressure. The solid would become a liquid. Okay. And what that means is, so when you apply more pressure, you are forcing the atoms together. And when you force the atoms together, it becomes more dense. So the solid would become a liquid. Liquid must, or liquid H2O must be more dense than water, liquid H2O must be more dense than water. Sorry, I keep saying, liquid H2O must be, I'll take my time, more dense than solid H2O for this to be true.
Professor?
Yes.
Yeah, when you say that something is more dense, does that mean that it's heavier than another thing? Or
It means when something's more dense, it means for the same volume, it has more mass.
okay.
Liquid H2O, yeah, sure. Liquid H2O must be more dense than solid H2O for this to be true. And since liquid is more dense, solid H2O floats in liquid H2O. Therefore, H2O solid floats in H2O liquid. And I'll zoom out a little bit so maybe you can see the whole picture there. So the slope of this line being negative, which water is about the only substance that happens for. I'm sure there's one or two others, but it is the only substance we run into in our normal lives that I know of which has a negative line for this. Every other substance, the solid is more dense than the liquid, so it doesn't happen. And what's amazing is that if this were not true, then lakes would freeze from the bottom up because the ice would sink. And then I don't know how the fish would survive in lakes, because usually or oftentimes if a fish survives, it stays below the surface that's frozen. Anyway, it's very interesting to think about. It has to do with the fact that water, H2O liquid, has more hydrogen bonds or more dense hydrogen bonds than ice, H2O solid. Anyway, very interesting. Any questions about it? Any other questions? If on the homework you get not water but carbon dioxide, the only difference is this line would have a positive slope. Otherwise, it's the same picture. And you'd have different temperatures too.